Let's talk about strong electrolytes, and I'm going to show you some of my favorite electrolytes right here. Good old Gatorade. And what do you mean by electrolytes, Mr. Chamberlain? Well, you may have heard that there are electrolytes in Gatorade and you need them. If you flip it over and look at the nutrition facts on the back, you can see some electrolytes. You see skip pass, water, sugar, dextrose, citric acid. We're getting closer, but let's not concentrate on those. Let's concentrate on salt, sodium citrate, and monopotassium or potassium phosphate. Each of those is an ionic compound, and in fact, they are a strong electrolyte. I'll show you what I mean a little bit more later by that, but they're going to completely dissolve in water in solution. And so if I look in here, I don't see solids forming in here. I don't see precipitates, even though all of those compounds are here together. That's because they're completely soluble. They're strong electrolytes. And they're also tasty. So let's talk a little bit more about strong electrolytes and what the heck that means. So these are salts that disassociate 100% into ions in solution. I'm going to show you that in a demo soon, so you can actually see what I'm talking about. And potassium iodide. When you put that into water, you will see it break down into potassium and iodide. Both of them are going to be aqueous. They're dissolved completely in water. That's that shell of water around each of the ions. However, lead iodide is an iodide exception. When you add it into water, we see that it stays as lead iodide. It stays as a precipitate. It's not going to dissolve in the water. So what exactly does that mean? Here we have table salt. We're going to shake out some sodium and chloride crystals into this water, and we're going to see what happens. Shake, 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 shake. Oh, they're going to fall. Oh, they're in the water. And you see we have red or pinkish sodium ions, and we see green chloride ions. When you put sodium chloride in water, it doesn't stay in its crystal form. It doesn't stay all locked together. It breaks down into its ions. That's because sodium chloride is a strong electrolyte. It very easily breaks down into the sodium and chloride ions. This works up until a reasonable amount. Of course, you're going to reach a stage in which it becomes saturated. And when it becomes saturated, that is when it's not going to hold any more in the water. There's not enough water to go for each of the chloride ions. Let's see if we can get to that saturation point here. Let's see. Shake, 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 shake. Let's see if we can get there. You see it's staying together. It's mostly in ions, but if you look down at the bottom here, we see some crystals. Just like if you added a lot of salt into water, you would notice that it is, some will reside down at the bottom while most of it dissolves into water. Granted, and you'll also see that it kind of looks dynamic. Some things are coming in, some things are coming out. Yeah, as things bump into the crystal, they're going to add the ions, or water might come in and pull some away. So that is a strong electrolyte. Sodium chloride is soluble. It's going to 100% dissolve up until a reasonable point. But let's talk about a slightly soluble, a weak electrolyte, such as strontium phosphate. Strontium phosphate, we know phosphates are insoluble except for our group 1As or our ammoniums. So let's shake out some strontium phosphate and let's see. Okay, let's see what happens. Well, we do see a few ions, but right away we see that a lot of the crystals are going to stay together. We didn't have to put hardly any in there at all. Some is going to, but this is definitely not 100% soluble because we just barely put any in there at all, and we see that it is already staying in its crystal form even though it's in the water. It is a weak electrolyte. It is in salt, and what I mean by that is not dissolved in salt. I hope that was helpful.